This is a 3D printed Assassin's Creed hidden blade made out of metal and plastic components. Today I'm going to show you how I made it and how you can make one too. Now let's go. What's up you guys, my name is Mark and welcome to my channel. I downloaded these files for free off Thingiverse and will have a link in the description below if you'd like to download them too. I wanted to make this hidden blade as realistic as possible, which is why I decided to make a lot of these pieces out of stainless steel. Now, I understand that a lot of people don't have access to metal 3D printed parts, so this design will work just as well with plastic pieces. I ordered my metal parts from JLC 3DP and it cost me about $120, but I'd be paying about a fraction of that if I decided to order these parts in resin instead of metal material. After I placed my order, I got my parts in about 3 business days. The parts came packaged really nicely with lots of foam padding and bubble wrap. I found that printing parts in metal doesn't sacrifice any of the detail and the tolerances are still pretty spot on. The parts do have sort of a bumpy surface finish to them, but I'll be smoothing all of that out with a Dremel and sandpaper. Here is a fully assembled plastic version of the hidden blade. I printed out all the parts ahead of time in PLA to make sure they all fit together and everything worked correctly. As you can see, when I pull on the ring attached to the fishing line, the blade shoots out, and when I pull on it again, it retracts back into the assembly. I think it's wicked cool and I'm super excited to show you guys how to build this. I'm now actually going to disassemble this because I'll be using some of these PLA pieces for my final build. I have all the parts for my build laid out here, and as you can see, there's a mix of metal and plastic parts. I didn't want to print everything in stainless steel because of how expensive things can get, but also because the end product would weigh a lot more if everything was metal. So these were the parts that I decided to leave plastic to reduce weight and cost. First thing I'm going to do is make sure that everything fits together and is within all the correct tolerances. Right away, I see that the metal blade doesn't quite fit in the case and it's actually too thick to slide out. However, this is fine because I'm going to sand down the blade anyway to give it a nice shiny finish. I use a Dremel and start with 80 grit sandpaper. After the 80 grit, you can see that it has a nice shine to it, but there are still quite a few scratches and imperfections. So I sand with the Dremel again, using 240, 400, and 600 grit sandpaper. After sanding to 600 grit, the surface looks better, but it still has some waviness to it. That's all fine. I'll wet sand and polish the surface to get rid of any remaining imperfections a little bit later. This same sanding process is repeated with the outer metal guard and all the other smaller metal components. If the metal surfaces aren't sanded, it can cause more friction between the parts and they won't move or slide as easily when everything is installed. After everything is roughly sanded, I use super glue to connect some of the small parts together. The first 2 items are part of the main gear mechanism. The next 4 parts are from the dual action launch mechanism that extends and retracts the blade. The 2 parts are connected with a spring, which I'll show later. And the last 2 parts that I'm gluing are the plastic assembly housing and the metal plate that keeps the blade from overextending. There are a few other items that are needed to complete this build outside of the 3D printed parts. I'll be using 3 rubber bands, a 1/4 diameter by 7/8 inch long extension spring, and 6 20mm M2 screws. One of the rubber bands will be cut and attached to the main gear mechanism. The rubber band can be stretched and worked in between the 2 grooves in the middle piece. A dab of super glue can be put on one side of the rubber band to lock it into place. After the super glue has been able to dry, the rubber band can be stretched again until it's taut, and another dab of glue can be placed on the other groove. I do a quick fitment check by placing the trigger in the middle of the mechanism. Everything fits great and the excess rubber band can be cut off. A Dremel is used to remove the remaining bits of rubber so the gear can fit over the middle section of the mechanism and spin with minimal friction. After the trigger is installed, you can see that it prevents the gear from turning one way but allows it to move freely in the opposite direction. I actually ended up not using these 2 small metal pieces. How these parts work is a rubber band is put in the grooves of the parts and they act as a locking mechanism for the blade. However, there was just too much friction between the metal and plastic parts, so I opted to just use the plastic parts I had already printed. These are already assembled with rubber bands, but you can see how much easier the plastic locking switch moves back and forth compared to the metal one. I wet sand the metal blade and outer guard with 1200 to 3000 grit sandpaper to obtain a better surface finish. I finished both parts off with polish to make them look nice and shiny. Now that that's done, I'm going to install everything again to ensure the functionality of the entire mechanism. I put the blade into place and you can clearly see the improvement after sanding. I connect the 2 launch slides to the spring and put those into place. I take the pre-assembled plastic locking switches and install them next. At this point you might be thinking, Mark, how does the blade actually get launched in and out? And that's a really good question. The key is this switch plate. When installed, this plate keeps tension on the spring. When the plate is slid forward, it disengages the bottom locking switch and launches the blade out of the case. When the blade is fully extended, the top locking switch engages and prevents the blade from sliding back into the case. To retract the blade, the switch plate is slid back and disengages the top locking switch, which allows the blade to propel back to its original starting position. Once back at its original position, the bottom locking switch engages to keep the blade from moving back out of the case. It can all be kind of confusing, but trust me, it works, and it's pretty freaking cool. This little gear mechanism is what slides the switch plate back and forth. Once the top of the case is on, this little knob on the inner gear mechanism sits perfectly in the switch plate. Next, the trigger and outer gear are installed, as well as the gear rack. Fishing line is tied to the end of the gear rack, so when it's pulled, it turns the gear, which moves the switch plate and propels the blade in and out of the case. A rubber band is attached to the other end of the gear rack to bring it back to its starting position after it's pulled. The top guard can be installed, screwed down, and now the whole thing is assembled. Easy as pie. As you can see here, the blade launches in and out when the case is level, but once I tip the case, the spring doesn't have enough force to launch out the heavy blade. Now, this was super frustrating, but I already had my suspicions that the spring was not going to be powerful enough to handle the stainless steel blade. As a reminder, these files were intended to be used with plastic pieces, so if you're using PLA or ABS, you shouldn't run into this issue. Anyways, to solve this, I pivoted and replaced the blade with one 3D printed out of aluminum I got from PCBWay. PCBWay is another company that supplies 3D printed components, injection molding, CNC machining, as well as custom PCB creation. They actually have a lot more material options for 3D printing, including aluminum and titanium. And I'm definitely going to be using them more for builds in the future. Aluminum is about a third of the weight of stainless steel, so the spring should have an easier time launching the blade back and forth. And as you can clearly see, it works so much better. Now that I've got the hidden blade assembled and working, the last step is to attach it to my wrist. I measure out some 1-inch belt strapping and super glue one of the ends to the case. I install some snaps on the other end so I can attach the mechanism to my forearm and easily take it on and off. I then install the metal ring I printed at the end of the fishing line so I can use a flick of my finger to activate the blade. Here are some shots of the finished build as well as some video of it in action. Thank you guys so much for watching. If you enjoyed this video, please give it a like and consider subscribing to my channel for more content. I'll see you next time, and stay classy.